So in this video of chapter number 13, surface areas and volumes, we are going to focus on volume of another three-dimensional solid figure, and here we are going to focus on the volume of cone. So far we have seen volume of cube, we have seen volume of cuboid, and we have seen volume of cylinder. Now the fourth geometrical figure that we are going to focus on is cone, and we are going to see how to find the volume of a cone. Now there's a very interesting way to find out the volume of a cone, and to understand or to know the volume of the cone, we are going to do a small experiment. So yes, hold on, let's get rid of this. Okay, so what we are going to do is we are going to take a cylinder and a cone. Okay, we are going to take one cylinder and one cone which will have the same radius and the same height. Okay, so let's mention that pointer. So this radius of this cylinder, okay, so radius of the cylinder is r. I'm going to say radius is equal to r, and that same radius we are going to use for the cone as well. Okay, so radius of cone, the circular base of the cone, r, is equal to radius of this cylinder. Okay, r, and height is also same. The height of cylinder is equal to the height of the cone. Okay, so it's a small experiment that we're going to do. Now once we take these two geometrical figures with the same radius and the same height, now what we are going to do is, in this cone I'm going to fill the water in this cone and start pouring it into the cylinder, and I want to see how many times I need to pour the water from the cone to the cylinder till the cone is full. Okay, and that will give us some idea about the volume of the cone. Okay, so if you start filling the water in this, basically indirectly we are calculating the volume of the cylinder, right? We start filling this water in the cylinder, and let's see how many iterations are needed from the cone to fill the cylinder. So, but this is very important point, that both of them have the same radius and the same height. Okay, so before we move on, let us just note down the volume of cylinder. We all know, so volume of cylinder. Okay, what is the volume of the cylinder? It is the area of the base, so it has a circular base, so pi r square, which is the area of the base, into the height. Okay, h. So let's do one thing. Let's make this radius as small r instead of capital R. Okay, small r. Okay, so radius is small r and the height is small h. So the volume of the cylinder is pi r square h. Now we want to find the relationship between the volume of the cylinder and volume of the cone. Okay, so we have taken both of these with the same radius and same height. Let's start pouring. Let's start filling this whole cylinder and pour into the cylinder. Fill this whole cylinder, cone, pour into the cylinder, and let's see what happens. So this is what happens. Let's come to this figure. So as you can see, this is the first iteration. I poured the cylinder, it got filled till this point. Then second time I poured the cone into the cylinder, it got filled in this point. And then in the third iteration, when I put the water from cone into the cylinder got exactly full. Okay, you can try this experiment if you want, but what happens is, 3 iterations of the cone is equal to one whole cylinder of the same radius and same height. That is a very important criteria. Okay, what does that mean? That means 3 times, okay, 3 times the volume of cone, 3 times the volume of cone is equal to 1 time the volume of cylinder. Okay, does that make sense? You have to take 3 cones to fill one cylinder of same radius and same height. I am repeating this point again and again because that is very important. Okay, so very interesting and a very simple experiment, but it gives a very powerful relationship between the volume of the cone and the volume of the cylinder. So 3 times if you fill, okay, this cone, then the cylinder will be exactly full. It won't spill and there won't be anything remaining from the top. It will be exactly full. And thus we can say this, that 3 times the volume of cone is equal to 1 cylinder. Now we know the formula for the volume of cylinder, which is equal to 1 times volume of cylinder is pi r square h. Okay, that's what we mentioned here. Okay, volume of cylinder is pi r square h, and thus we easily get the volume of cone here, and therefore volume of cone will be equal to what? So this 3 will come to the right hand side of the equation. So it's going to be 1 by 3 the volume of the cylinder, which will be 1 by 3 pi r square h. That's it. Let's box it. This is the formula to calculate the volume of any cone, okay, which will have this radius r and this height h. Quite simple and straightforward, quite interesting way to derive the formula of a solid figure. Okay, so this is standard formula to calculate the volume of cone, pi 1/3 of pi r square h, which we'll be using to solve a lot of unsolved problems. That's it.